So now look at what we mean by conjugate. So we use this when we have a single radical denominator. We use this concept. The idea of a conjugate is simply this. So if you have an expression a plus b, its conjugate, so given this, the conjugate is a minus b. Simple as that. Just change the sign in between the two of them. Alright? That's all you need to do to get the conjugate. So what happens when you multiply something by its conjugate? So let's do that right here. So when I multiply a plus b with its conjugate, a minus b, what do I get? A times a squared. A times negative b is minus ab. Positive b times positive a is positive ab. These two can cancel out. And positive b times negative b is minus b squared. So these two cancel off each other. So all I'm left with when you multiply anything with this conjugate is the square of the first term minus the square of the second term. So you can figure if there was a radical in any one of these, the square is going to undo the radical. So, example, if I add that now, so if I had root a plus root b, the conjugate of it is going to be root a minus root b. When I multiply them out, if I follow the same pattern, I'm going to get what? Square root of a squared minus the radical of b squared, which is a minus b. Because the square root of a squared term is the value itself. Right?
Why do you put the AB and AB in the middle?
Where?
In the middle.
In the middle?
Yeah,
What's in the middle?
Then you X out up top.
Then cancel out. I'm just showing what happens when you multiply something that's conjugated.
Okay.
And then that the insides are going to cancel off each other. So you also end up with those two square terms. Which is the same thing. Remember when you did the difference of two squares and you factorize it? It's going from this to that. Now we're going in the reverse. Okay? So I want to look at some examples of that one. So we have example 3, so do example 4. I'm going to start with a simple one. I'm like right on time, I'll go very fast. 5 minutes. So example 4, let's say I have 5 over 2. Let's do something like negative on 4 minus root 2. Alright? So that's what I have. Department of close. Okay. I want to, that's a division, so I want to simplify. So I have to use now, I want to rationalize the denominator, but in doing that, I need to use the concept of the conjugate. Yeah? So I'm pretty much using this, but I'm going to multiply both the numerator and the denominator by its conjugate of the denominator. So I'm going to multiply, what's the conjugate of this?
4 minus 2.
No. Plus.
The conjugate, not the rational.
Alright? The conjugate of it is just a change of sign. So it's 4 plus root 2. And at the top, same 4 plus root 2. So when you multiply it, I want you to just go straight to here. So I'm not going to do the whole long district. So it's going to be what? This square, which is 16.
Yeah.
Always minus this square, which is going to be what? Root 4. Right? What is root 4?
2.
So that's 2. What is 16 minus 2?
14.
So my denominator is going to be simply 14. So this sort gone out of a denominator, which is what we wanted to do. So what's the numerator going to be? So 5 times this. So 5 times 4 is going to be
20.
plus 5 times root 2 is
2.
5 root 2. Understand? So if we want to break it up into single fractions, and we can reduce a bit, so I would have 20 over 14 plus, I could write this way, 5 over 14 over 2. You can also do it. And then this fraction can reduce to what?
Can we reduce to
10 7.
10? Yes. And 1
10 over 7 plus that. So that's what I reduce. 10 7.
and 1 7?
No, just leave it. No mixed fraction. So you could go down to this if you wanted to. Sometimes the question asks you to give your answer out into a plus b root 2 or something like that. So a would be this fraction, b would be that fraction root 2. Okay?
Yes, sir.
See a different type of example now when you have two things up top to So example 5. Let's say I have now 3 plus root 2. My denominator is root 2 plus 5. Right? That's my denominator. So we're going to rationalize this again by what? Multiplying my denominator by its conjugate, yeah? So multiply top and bottom here by what's my conjugate? Root 2 minus 5. And this is going to be root 2 minus 5. So we want to first work on the denominator, which is what where I want to get to. What's my denominator going to be? Root 2 squared is root 4.
Which is 4.
And then minus this squared is going to be 25. Root 2 squared is root 4 is 2. 2 minus 25 is simply
23 minus 23.
negative 23. So that's my denominator. Just want to figure out what my numerator is going to be. So let's do this here and then simplify and put the final answer over there. So 3 times root 2. That's simply 3 root 2, correct?
Yes, sir.
And 3 times negative 5, that's negative 15. Then I'm using this root 2. So root times root 2 is positive root 4. Positive and negative is negative 5 root 2, right? So I'll do some simplification.
Oh, yeah. My bad.
Look at this times this. This times that. This times this.
Okay.
This times that. So I can group my root 2's. So 3 of them minus 5 of them is going to be minus 2 of them. Agree with that? 3 of something minus 5 are the same things. Negative 2. What happens here now? This root 4 is 2. So I have negative 15 plus 2. So that's going to be negative 13. And that's the final answer. One last example, Erica, and then I'll go to example 6, and then we'll stop right there. Let's make both radical in the denominator just to see what it looks like. And I could have done next example now with time. So I'm going to do, let's say, 2 root 7 here minus 3 root 4. Okay? And on top, I can put just something out there too. So let's do, I'm going to make this as tricky as out. I'm going to use different surds. So I'm going to have 2 root 3 up top here plus 5 root 5 root 2. Alright? So what we're going to multiply this by the numerator and denominator by what? The conjugate of this denominator, which is going to be 2 root 7 plus 3 root 4. So up top, 2 root 7 plus 3 root 4. Right, so when you're watching this again, you can pause it, work it out, and play out the video and see where you reach. Right?
Yes, sir.
So, alright, so let's get it in. So we just want to write, work the denominator part first. So square this number. So 2 square is
4 and then 49.
4 root 49 minus 9 root 16, yeah? I'm going to simplify that. So let's put the final answer down here. So it's going to be 4 7s 28 minus 9 4s. So it's 28 minus 36. that negative 8. Okay? So negative 8 is my denominator. So let's see what I'm going to do up top here. I'm going to extend this and then simplify it right there for final answer. So 2 root 3 times 2 root 7. 4 root 21. 2 root 3 times 3 root 4. 2 times that.
Oh, sorry.
6 root 12. 6 root 12. Good? And then this now, this times that is going to be 10 root 14. Notice now all these are different. Can't group them. And this is going to be 15 root 8 plus 15 root 8. There's nothing there to group, so all of them come right back on top of this. So when you have somewhere you have similar surds in numerator and denominator, something may get a whole number up there, but it's like this, all different. No, because root 21, root 12, different surds.
And 3.
Right? Unless you want to convert some similar surds here. So this can break down to root 3. Can I root 3 of this? I root 3 of this. I can root 2 or root 2 of this. That's what you could do. But unnecessary. So just write that back. 4. So just 4 root 21 plus 6 root 12 plus 10 root 14 plus 15 root 8. Final answer there. And that's it for us for today.